Hello all, welcome to the course of Signals and Systems of your next semester subject. So the Signals and Systems basically is a course which is related to electronics and communication engineering or electronics and telecommunication engineering. And these signals play an important role in communicating from one point to another point, or from one person to another person, or from one point to another destination. And the systems play a crucial role in transmitting and receiving the signals from one point to another point, or from one destination to another destination, you can say. So in this course, you will be knowing about different types of signals, the basic definition and classification of signals, and different types of systems, and what are the operations we are going to do it on signals, and different concepts related to correlation. Correlation is how closely two signals are related, and convolution, how do two signals convolute, and what is the analogy between vectors and these signals, and we will be dealing with orthogonality and mean square error parallel. So the textbooks related to these signals and systems are Oppenheim and Scheffer and Simon Hawking. These are the two textbooks which are being prescribed for undergraduate students, and B.P. Lati, Principles of Linear Systems and Signals, and Sairiku. These are another two reference books which you can go through to understand the signals and systems. So first of all, we will try to know what is a signal. So signal basically it is a physical quantity, and it is defined as a physical quantity because it varies its position with respect to time and space. So anything which varies its position with respect to time and space, or time or space, you can define it as a physical quantity, and most probably it is a vector quantity, that is, it will be having a magnitude, and parallelly it will be also having a direction, that is, signal will be moving in one particular direction. So it is a physical quantity and a vector quantity which varies with respect to time or space, or independent or dependent variables. Now these signals are basically waves. Normally when we go through physics, we will be dealing with different types of waves, longitudinal waves, transverse waves, sound waves, different types of waves we will be studying whenever we are studying this physics. But what essentially differentiates a signal from a wave? Signal is a type of a waveform. It is a physical quantity and it varies with respect to time and space, or time or space. So it can be defined as wave, but what differentiates the wave and a signal is, the signal should essentially convey some information. Signal should essentially convey some sort of information. That is why it is defined as a single valued function which carries information by means of amplitude, frequency, or phase. So a signal should essentially carry some information. So that differentiates between a wave and a signal, and these information can be carried by amplitude. Amplitude we will be seeing in the next slide. Amplitude, frequency, and phase. See, this amplitude, frequency, and phase, these are the characteristics what we study whenever we are studying about waves. So suppose the different types of signals, voice signal, or a video signal, or signals on telephone, anything can be a signal. You can deal it as a signal. Now here you can see x of t is equal to a sin omega t plus pi. A sin omega t plus pi, where a is the peak amplitude. Peak amplitude is the amplitude of this particular wave, that is from this line or this arrow mark on which time is being depicted, from here to the maximum value, maximum instantaneous value is called as the amplitude, or you can define it as the peak amplitude. And f is the frequency. Frequency is number of cycles per second. That is, frequency is number of cycles per second in the sense how many cycles are being generated in 1 second of time is called as frequency. And the formula for frequency is given by f is equal to 1 by t, or you can write it as t inverse, that is t power minus 1. Okay, and this pi is the phase angle. Pi is the phase angle. That is, phase angle is the angle at which the wave is going to start. So if any wave is going to start at a particular angle, it is going to end at that particular angle mostly. So, or it returns to the same angle where it has started. So phase angle is one of the characteristics what we study while we study these waves. And second, and the last one is angular frequency. Angular frequency, or you can say it as linear frequency. So what is the difference between frequency and linear frequency? Normally, the frequency is number of cycles per second, but when it is coming to waves or signals, we will be dealing with angular frequency omega. Angular frequency omega. This is why, because the waves, especially in communication engineering, we would be using these electromagnetic waves, which has a property of curling. Curling is completing one complete rotation in a given time period, that is 1 second. Time is basically, we scale it in seconds, and the basic time is 1 second, and they complete one complete curling, that is 360 degrees in 1 second. So that is why whenever we are dealing with these particular signals, we, rather than the term frequency, we would be using the term called as angular frequency omega, where omega is equal to 2 pi. 2 pi is 360. 2 pi is 360. Pi is 180 degrees and 2 pi is 2 into 180, which is 360 degrees, into f. F is normal frequency. That is, you can substitute also the value of f, that is 1 by t. And then you will be getting the final equation as omega is equal to 2 pi by t. This is about angular frequency. Rather than frequency in signals, we will be using angular frequency. And you can see here in this particular slide, you can see this is the peak amplitude. This is called as amplitude, and this is the phase. Suppose this wave started at 0 degrees. This wave completely started at 0 degrees. Practically, no wave starts at 0 degrees. Even sin 0 is 0. There is no chance of a wave starting at 0 degrees. It would be just more than 0 degrees. And this wave, they are depicted as 90 degrees in this particular picture, which is taken from Simon Hawking. And this is the peak amplitude of that particular wave. And for this wave, this would be the peak amplitude. And time period is, you can say it as, it is the time taken to complete one complete wave cycle. That is, one node and one antinode. The top ones are called as nodes and the down one are called as antinodes. So the time taken to generate one complete wave is called as time period. Okay, and this one is the amplitude completely depicted, and this peak one would be the amplitude. Okay. Next, classification of signals. Different types of classification of signals. So these signals are again classified into 1D signal, 2D signal, 3D signal, where D stands for dimension. So if it is having, or if the signal is a function of only one variable, or if a single value varies with respect to time, so it is called as one-dimensional signal. One-dimensional signals are normally audio signals or biomedical signals or temperature signal. And these are the basic 1D signals what we see. So they vary in only one dimension, not in multiple dimensions. Next, second classification of signal would be two-dimensional signals. So if the signal is a function of suppose two variables, suppose time and phase, or space and time, okay, or space and phase. Suppose if it is varying in two dimensions, it is called as a 2D signal. Suppose you can say that image signal in which intensity is function of two spatial coordinates, that is x and y. Image signal, normally the photographs what we take, you will be having two spatial coordinates, that is x and y, that is you will be having the object would be at a particular distance and you will be having a pattern or a breadth of that particular image, which is called as a 2D signal. Suppose now 3D signal, video signals are 3D signals. Now normal photograph signals, they won't vary with respect to time, but when it comes to video signals, they vary with respect to time, that is the image changes with respect to time. That is why it is called as a 3D signal. If the signal is function of 3 variable, or if the signal value varies with respect to 3 variable, it is called as 3-dimensional signals or 3D signals, for which you can write it as an example of video signal in which intensity is function of two spatial coordinates x and y and also time. This is the classification of different types of signals. So what we had seen is basically the introduction to signals. So we had seen 3-dimensional signals, 2-dimensional signals and 1-dimensional signals, and we had seen the subject overview in this part 1 of our lecture. Okay. Thank you.